Hi, car's now back from Chris's place. Exhaust all nicely prepped, about as far as we can go. We didn't finalise the position of the end of the exit, so basically this is on, I can rotate it and move it up and down the pipe wherever I need it. We also have a detachable point here, so if we need to have a meter specific track limit, if the car ever goes into a track and has to be a 97 decibel day or something, we can fit another silencer, or even do a weird S pipe or whatever we need to do there, and leave the room basically so we can have additional silencing here. But for the road, the one silencer is probably going to be plenty enough. Obviously lambda port at the top, lovely merge collector. Just lovely. This is a double slip connector. Basically there's two tubes coming this way and two tubes going that way. So the exhaust gas would have to do a double S to come through, and apparently once the exhaust starts to heat up, they basically end up touching each other, and to the point where you can even put these on the pressure side of a turbo exhaust manifold, which was a surprise to me because I felt sure it would leak, but been told reliably that they don't, so seems to be the latest tech, and obviously it will allow me to rotate the exhaust. If I need to alter this angle and bring this down slightly, we can alter the bracket, alter that, just to get everything tweaked as perfectly want. So we have built in, or so I say Chris has built in a lot of adjustability for me, which is perfect. So but yeah, that's the system. So engine 7/8 pipes, I think, for the primaries. Obviously the header plates that we machined up with the nice transition from oval to round tube. Yeah, it's just gorgeous. Anyway, I don't want to blow too much smoke up his ass. We might start putting the prices up. So yeah, one side done, and the second side. The headers are reasonably equal length, to within less than an inch. There are slight variations left to right due to the water pipe that runs underneath here. So it doesn't quite marry exactly, but you can't, because one head I can get more clearance for. So realistically, we've allowed for both. So yeah, it's gorgeous work. So. And obviously if the customer wants to change the tip for whatever reason, slide it off, another one on. So I like the ability to be able to change it if we need to. Anyway, that's the exhaust. Been building for a while. I've been redoing all the sides. Now you can see with the door on, that pretty much the side of this, actually I've got a straight edge. And here we go. We've got a straight edge here, and pretty much got a straight edge now all the way down. Tiny bit of sanding, and all the rough edges will be pretty much gone. So door fit here, all along the bottom, top, within fileability. Obviously this is, unfortunately this piece we had to cut off because it was so badly twisted in this direction that bending it back was causing us a lot of issues. Now, eventually we found out that bend was here, which is why this was cut off. It wasn't cut all the way through, it was cut to here, but then we basically bent this round, so now you really see this bodywork just curl into the wheel, and the back edge is straight, which is what it should have been. And then we can now place that and get that back to where it should be. Unfortunately, this here is still slightly incorrect. It's pulling that way. It's basically pulled as of the fiberglass again. So yeah, again, I've got to cut this off here, lay it back to how it should be, correct it, and then relaminate it from both sides. So I've actually laminated this side back in again, ground away the first layer of the gel coat, and put a couple of small layers of glass through there. So we've got laminations on both sides, so the cracks can come back through. This was originally joined here. You can kind of see where the thickness of the second panel would be, but we've cut it off to make sure everything's correct. So And obviously got to cut out from laminate that up black up flat to put in the new joints, the new catches, so we say. You can kind of see that one's panel and that's sticking out. Well, when this gap is brought all the way back, it actually sticks out about 3/4 of an inch. So more work to do. Now, as much as the door is pretty good around here, as you can see at the back, it's awful. We do have to lift this back up just a tad, probably only about 1/4 inch or so, but I've still got a lot of work on the door to bring that back down. We have actually got a plastic racing screen now, a Lexan hardened coated racing screen, which once the car is registered with the full glass screen, it gives the customer an option of what he wants to do. If he doesn't want to damage the extremely expensive glass screen, you can put the Lexan one in. It's actually a darn sight stronger than any of the glass. It's 1/4 inch thick Lexan, and basically you can hit it with a bloody sledgehammer and it unlikely will crack. It will just push the sledgehammer back. So imagine for small debris that's going to come up and hit his what's basically a $4,000 windscreen. It's not going to be as risky, shall we say. So yes, bodywork, exhaust, bodywork to more to continue. Oh, here's the rear clip that we've cut. We cut through here and did the same on the other side, and basically pulled these sides back down, weighted it up and laminated back in. So the rear silhouette is basically now similar to the actual car itself. Well, the rotors have arrived, 345/32s, AP floating discs, J-hook design. These are the slightly lighter discs. You can get some more of an endurance racer, which technically are thicker here. Same width, but they have less vent and more thickness to the steel. Realistically, it's going to be a road car, and the likelihood of wearing these out very quickly are pretty small. So, plus the rotors aren't that expensive. They're about 350, 360 US dollars a piece. So, you know, really it's $1,500 or $1,600. Then you probably changed all 4 corners again. So it's not that expensive. So yes, they're floating. You can see the floating bobbins. So that'll allow for thermal expansion if you do actually manage to heat them up. Rather large, and we shall compare them just for a laugh. This is a 1979 Malik single seat racer. Has 13-inch wheels. And just for a complete and total laugh, this is a 14-inch rotor. It's almost as big as the wheels. So yes, now we have the rotors, the calipers. I've got the handbrake calipers to buy, and some cables, and pretty much the brakes are done. So we're knocking them down. Still got lots of body work to do. Got to finish marrying these two panels to each other. I've still got some work there. Yes, lots of fiberglass. Well, quick one on the Malik. This came to me as a running car. It's been, racing car, I should say. It's not really, not registered on the road. The gentleman that bought it needs some adjustability in the pedals and seat, because his wife's about 10 inches shorter than he is, and technically she wants to race it as well. Apparently she's the better racer, but he didn't want to admit that one too much. She's actually quicker. She's about 50 pounds lighter, I thought, so stands to reason. But anyway, here was the original pedals. Not exactly what you call best of road quality type of, more race car, very light, nothing to them. Was a mechanical clutch. We've had to convert that to a hydraulic. Yes, very basic. Good old twin DCOE Webers. Takes me back to my old Dutton days. There you go. Fun. 1600 crossflow. Well, I think it's a 1600 crossflow, so it could be 760 for all I know, but 1600 crossflow. It's got a Quaife 4-speed dog box, and it looks like it's a Salisbury or an English axle from an old Ford. But, you know, 5 linked, or Watts linkage, so technically 6 linked. Anyway, so we took the pedals out, and this is the actual pedals that were just robbed out the 962 temporarily just to mock up and see if they fitted. Do a small modification, chop the top of the clutch pedal off just by a short amount, just to miss the frame. We've raised the pedals up, but the passengers for the driver's feet's going to be a little bit lower than that, so might need to build a pad for him depending on how it feels for him, so him or her, sorry. But yet again, seat runners, but on this car there will be a little bit of more of palaver to adjust it. Obviously, the last thing I want to do is the damn thing to unlock. So we've tensioned the spring up a bit, and we've made it so that you basically have to take a device of some sort and push the lock out. So basically you can't accidentally unlock the pedals without meaning to, shall we say. It's not going to happen. If I can just might be able to, there we go. So unlock the pedals from here, or physically just push them back. There we go. So we've actually got 6 inches of pedal movement. We looked at what was required between him and his wife, and his wife needed about another 4 inches. So we've got 6 inches of pedal movement, which is good. We found a few silly things while taking it apart. There's a real bad a fuel fitting that would have leaked soon, that was cracked. An incorrect brake pipe, which drove me nuts as soon as I saw it, because I realised they're just old Enots fittings. Oops, seen the video cut off. I'll start again. Yeah, basically the fittings that were here that connected the original master cylinders, which are these here, the masters are fine, were wrong Enots fittings. They were not proper flares, they were not proper brake fluid, so that was dangerous. So we actually found quite a few minor problems with this, which could have turned into serious ones. The steering rack joint, the steering column joint was starting to wear pretty badly. We had about 15 degrees steering with no input to the wheels. The brakes had a problem, the fuel had a problem, and the seat has a problem as well. This is an old race car, so, and again the seat has a bit of a indexing problem here, and basically see here, it's not very well attached. So if you can imagine, this seat attaches to these 2 parts here and there, and what you see underneath here is what the seat sees at the back. So basically when the seat fails, you end up, well, riding on a piece of aluminium at the floor, which surprisingly enough is coming away from the floor. It's hardly surprising because the actual seat was resting on it because it wasn't being supported. So yeah, there was a few minor issues. But this roll bar is going to be cut off, and we're going to widen it out here. Basically give the driver a bit more elbow room, or a bit of shoulder room, sorry. But also this puts obviously the tube into an eggshell. So if you can imagine, it's bent outwards, so really any impact that way is spreading the loads even easier to the 2 corners. Instead of in a bending load, you're putting less bending load in it, you're actually putting more force in the 2 corners. So bending the tube out actually gives you a little bit more protection as it happens. So yeah, we've got some work to do with this. Raise the steering column, not whether I said that or not, but not too much, you know. Probably a week's working complete to do the whole thing, so it's not that bad. Anyway, yeah, Malek aside, steering's obviously been moved on since the last video. I think I mentioned we put a double joint in the steering column. The reason was basically to lift the steering column up so it keeps it even further away from the pedals. It is extended above where there would basically be a flat panel, so it will have a little removable piece that will make up, so that basically you can remove that to service the joint if whenever you have to, or just do some safety checking. So yeah, a double joint obviously incorporates the fact you've got to have another support for the column. So we basically have a single joint at the top, normal single joint here, and then a support here, and then a double joint. But that gives us another couple of inches of room above the pedals, and basically means that the column won't interfere with anything, which is which is what we don't want. So yeah, it's just tacked at the moment. We've just got to finalise that off. We've got the positioning this lovely now, so it's this joint is in a 50, the angle there and there is 50-50, so I'm happy with that. We used conventional inner steering joints. When we had that spec'd up, we basically did it from there to there. The outer joint is still a rod end, but effectively we have built a second aluminium piece at the bottom here, so we put that bolt in double shear. It just spreads the load a bit more. We're just spreading it down. It becomes the diminishing returns of force, should we say. So really we're just spreading everything out. Happy with the rack. Steering geometry, awesome. Shouldn't be any different. Basically we built it to the CAD drawing, and the CAD drawing said 0, so yeah, we dialed the bump steer and yeah, we're 0. So as near as damn it, less than 10 thou over the whole wheel, over full bump, and most of that, to be totally honest, is in its full droop position, which you're not really going to get in racing conditions. From about 10 mil off the full droop upwards, it's virtually 0, so which is cool. So yeah, all the suspension's jacked down at the moment from when we had it transported, so basically the car's probably about 2 inches higher than it should be at the moment. Just did that to get it on and off the transporter. So yeah, steering, windscreen, brakes, exhaust. The car's moving on. I'm not going to get a huge amount of labour into it, unfortunately, because I've been working in a few places and not here, unfortunately. Now I've got a course to go on, so it's going to be another 2 weeks where I'm basically not going to be able to do any work to it. But yeah, really happy about the side now. That's like awesome. That side's pretty damn flat, so I'm dead happy that it gives you more motivation to carry on and get the next thing that's wrong out the way. So anyway, yes, I'll speak to you soon.